welcome back to Spring into Math 7. I'm Mrs. Campbell. Today we're going to be talking about experimental probability or real-world probability. Let's jump in. Probability is actually based on simple facts. Wonder if you knew that. So for example, since there's two sides of a coin, heads and tails, and each side has an equal chance of turning up, it makes sense to say that the probability of heads turning up is 50%, or 1 to 2. So it's pretty simple. However, making sense and being true in the real world, they're often two different things. Now, it may make sense to say that the probability of heads is 50%, but does a real coin in the real world actually turn up heads 50% of the time? So to answer that question, we're going to have to learn about experimental probability. And that's exactly what we're going to do. You might want to write this definition down. Experimental probability is probability based on doing actual experiments. Flipping coins, spinning spinners, maybe picking ping pong balls out of a jar, and so on and so forth. Now, random sampling, we've talked about this before, that's also an example of an experiment. The experiment is called the survey topic. Here's an experiment using heads and tails. Let's look at this example. Juan thinks that his lucky coin is lucky because he gets heads more often than tails in a coin toss. The reason he believes this is because he seems to get several heads in a row when he tosses it. He conducts an experiment and records the results. And you can see H, T, T, H, H, so that represents heads and tails. So using this data, we can find the experimental probability of getting heads with Juan's coin. First, we're going to find the number of total tosses, the number of heads, and the number of tails. So in 40 tosses, he had 23 heads and 17 tails. Now, we can make ratios to compare the number of times Juan gets heads to the total number of tosses and the number of times he gets tails to the total number of tosses. So same thing. So we have the total number of heads over total tosses, total number of tails over total tosses. So 23 over 40 and 17 over 40. So for the coin to be fair, we would expect that both heads and tails ratios would be 20 over 40 or 50% of the time. It actually came out to be 23 over 40 or 20 to 40. And that's higher than 20 to 40. And that's why one may think his coin is lucky. But this difference could be due just to a random chance, basically. So doing more trials, flipping it a few more times, that would definitely help to get a much more accurate answer. So sometimes in order to really see results, you may want to conduct up to 1,000 times trials of an experiment. Here's another important term to write down. A probability simulation is an experiment designed to determine a probability from many trials. Large probability simulations are done a lot of times using technology. So the next slide shows the results of trials of 100, 200, 500, and 1,000 of Juan's coin. By changing the ratios into percents, we can see results starting to get to the equally likely probability. However, the trial of 200 shows us that experimental probability does not always come out like you planned. So if you need to, take a minute, pause your video, and look at the data that came out of those flips. When you do an experiment, some of the results may look a little random. And because this happens, it means that we always get an approximation of the true probability. But the more trials we do, the more accurately our experimental probability will match the theoretical probability. And theoretical probability is just like it would be the perfect result using mathematics. All right, everyone, that does it for this lesson. Thanks for joining us. We'll see you next time. Bye-bye.